things. Example biomarkers coming from here, respiratory intensity and variability are affected by COVID-19. We know these things. We're starting to see this sort of health pattern coming through, these different biomarkers really coming through with speech. When we phonate, again, our use of our vocal folds can change when we have different conditions, such as things that affect our musculars, ALS and MS being some examples. We can look at things like jitter, look at things like shimmer, these actions of the vocal folds, harmonic to noise ratio, and monitor decline in these sort of conditions. Finally, with articulation, again, we've got to use all these muscles in our throat, in our jaw, in our teeth, lips, tongue, everything complicated in this meaningful manner to produce a single speech sound, let alone multiple speech sounds in a row. Again, it's very easy to interrupt this. We know that mental health disorders, things like post-traumatic stress disorder, actually come about with a bit of speech motor control errors, start to interrupt vowel space errors. Speech sounds a bit more slurred, a bit more similar, less unique in many, many different ways. So as you can see, this real build-up, this real richness of health information embedded in sort of every aspect of speech production. Why, if it's so simple for me to just name all these biomarkers, why do we have to use AI in all of this? Can't I just start measuring some things through signal processing and start to use this? The problem is that while speech is uniquely combination of cognitive, neuromuscular, physiological information, a lot of this information is non-specific towards different health disorders. So things like slowed speech rate can be associated with a wide range of things. I could be speaking slower because I've got MS. I could be speaking slower because I'm depressed. I could be sleeping slower for a variety of different reasons. We need to look and find very specific patterns related to different disorders. And the only way we can really do this is by getting AI in there. We need to sort of tease apart lots of different things that can be happening. You can see this range of different speech features, different conditions coming through. How do we start to pull all these apart? AI, training sets, testing sets, doing all this sort of work, trying to identify these patterns. And we can use machine learning specifically to find these unique patterns in speech data. And we can use these in health through supervised learning, so outcome prediction or diagnosis, or things like clustering, trying to identify unique cohorts based on their health, or subtyping different populations. So different clinical subtypes of depression, for example, might undergo different treatment forms. So it might be useful to use speech as a marker to identify these. So we don't even have to do things in a supervised manner to actually able to us to get really useful health information there. And does this combination of sort of health and AI work? And the answer is, well, sort of. We sort of know, coming through a lot of the different challenges that happen through interspeech and other things like fatigue, intoxication, Alzheimer's, depression, Parkinson's, childhood disorders, we can classify these, we can get regression scores against these, but we're still sort of struggling to get very, very specific, very highly rated things here. So conventionalists typically on this slide, something like a support vector machine classifier, state of the art would be some sort of neural net with these. So to overview where we are sort of more now in terms of speech and AI, I thought the best thing to do was actually just to look at what's been happening over the past 3 years, which has been the pandemic. And there's been a massive amount of research efforts going into trying to find cough, speech, breathing-based markers of COVID-19. There's been a huge amount of resource happening through here. And state of the art is sort of converging a little bit. We're sort of going back to doing things using MEL spectrograms, MFCCs, very sort of high level representations of speech, and using the power of different CNNs, different LSTMs to really try to break these markers. This, to me, starts to ask more questions and answering them. What are we really measuring here? What do we really know about what's going on? And one of the bigger problems we have in this field is often a lack of insights into all the comorbidities that might be happening, different health conditions. How can we potentially be biasing our data through our data collection? What are these results measuring? And right now, we know there's signal in the data. We know we're measuring something to do with a change in health state, but I'm not really convinced that we know what we're measuring. We can see this across different challenges as well. There's sort of real convergence onto using backbones existing things like VGGNet or just trying to do some CNNs on ML spectrogram. And this sort of state of the art isn't limited to just COVID-19. You can see these approaches coming across in a range of different papers coming out over the past couple of years. This seems to be the real way to solve things at the moment in terms of getting papers published in high profile sort of examples. And even still coming through in the literature, you can see an imbalance a lot. We still have this contemporary versus conventional trade-off, this small versus large data sets happening a lot. So we see really conventional pipelines built on smaller data sets, handcrafted features, looking at things like jitter, shimmer, formants, with random forests with support vector machines, through to the more contemporary approaches, sort of using spectral or end-to-end systems or deep embeddings learned through transfer learning, and into contemporary models, CNN and RNNs. And these are often utilized through transfer learning because we don't have the data, we don't have the power that a lot of other areas in speech do have, in particular speaker recognition, ASR. We're not even close to having these huge data sets to really uncover what's happening in terms of health and speech. So model choice is really driven in this field by two parameters: data availability. Do I have enough data to essentially train a deep learning model? And development time and resources. A lot of groups in this area, sometimes smaller, sometimes don't have access to the big, huge GPUs that powerful corporations have. So we tend to not use those approaches as much. And we've got to also remember this trade-off between complex modeling, needing more time versus overfitting. If we're starting to power up our models with huge, deep, complex models, are we just really overfitting to the data that we have at hand? Even when we're using independent test sets, this is still very possible to do, to produce non-generalizable models. So I've raised a lot of issues, a lot of concerns here, and there's a lot of challenges that we need to overcome. As I said, the bigger thing here is that we're getting signal. We're getting something, we're measuring something to do with health in speech. Now what we've got to do a little bit more is look inwards, start to look backwards a little bit and start to uncover, pull apart what's really going on. And there's a few different ways we can do this. We have limitations. We have a smaller number of data sets. These data sets are often recorded individuals once. We just take a health label associated with this one single thing that we're interested in, COVID-19, for example. We don't take things like their general anxiety, their level of fatigue, all these other factors that could be affecting speech. We don't look at individuals longitudinally enough. How do speech variations happen over time, and how do these affect these markers that we're trying to look for? Just something simple as change of time of day that we record the speech changes the acoustic parameters of the speech. We do not know how that affects health models yet. We're just still gathering these sort of information, pulling this evidence together. As I've already said, we're missing insights related to comorbidities, how different conditions such as Alzheimer's condition, are we really measuring Alzheimer's? Or are we measuring some depression associated with these Alzheimer's in these patients? These are the sort of questions we need to start answering now as a field. And we also need to start incorporating more insights from patients into our own research. And I'll talk about that more over the next couple of slides. And this is what I've highlighted as these urgent next steps: more data collection, more data augmentation, looking for strategies to share data. That's going to help all of us. We need to have increased attention on algorithmic explainability, having a look and seeing what are our models learning? How is this useful? How is this providing clinical information? Does this match up with what we know from the literature or some hypothesis that we might make in advance? We also need to think about increased co-design. So including clinicians on our research, but also including patients in our research through public and patient involvement. We also need to think about adopting more standardized reporting across ourselves as fields. Everyone reports a different little mismatch of different metrics and things. So there's real need to start to standardize things more. We can do more meta-analysis. We can start to show the real power and the real benefit of our work to more skeptic sort of clinicians who might be, oh, speech, I'm not a bit sure about that. If we work together as a community, we have this massive opportunity to really come about and bring speech into a health marker. So I put that goal there as, put this goal here as trying to get speech models validated through clinical trials within the next 10 years. The only way we can do that is by working together as a wider community to really get this done and start to build things up. So as I said, this first issue is data collection, and it's really imperative that new data sets are introduced. I know one thing through my work in the sort of more clinical field, some clinicians use data sets 3 or 4 times and then throw them away and start to look for new evidence on data sets. We as a field use data sets hundreds of times, albeit we're approaching the data and using the data in slightly different ways, but it doesn't help taking our arguments into clinicians when we're just over testing essentially on data sets and starting to overfit to them. We need to develop protocols that actually support our modeling. So one thing that we do at the moment a lot in the field is get speech from a clinician from some sort of clinical interaction. This clinical interaction will allow us to find a bit of difference between A versus B, but that might not be the best way to find these. There might be better ways to start to think about speech elicitation prompts that allow us to start to separate out different factors and how these will work better in our models to begin with. And we also need to look at sharing data resources. So the anonymization efforts that were talked about in the last talk are coming through also into the health work. And this is really good because it might be a way that we can start to anonymize data, keep the health information in there and share it around easier as a community. Data augmentation, of course, is happening more and more in the field, but it's quite a tricky thing to do in health. We can use simple things, time warping, frequency masking, time masking, but if we're not careful about how we do these, it's very, very easy to change class membership while we're doing them. We can look at more advanced things such as generative adversarial network or speech synthesis, but while we've still got small data sets, it's exceptionally hard to get generalizable, wider speech that's not going to cause our systems to sort of overfit through these. So data augmentation looks interesting, looks promising, but we've got to be careful again about how we do this. Of course, self-supervised learning seems to be exceptionally interesting. There's a lot of papers coming out here at this INTERSPEECH, more so than ever, utilizing this. And it's good. There's these ways now we can start to learn more from inputs in one part of the data to help inputs in another part of the data. We can reduce reliance on large amounts of labeled data, which is one of the main problems we have in speech and health. But some interesting work that was presented yesterday in the speech and motion session was just showing how we could just start to think about tasks to learn better representations within this data. So not so blindly, but starting to look for ways that we could actually go, this is something related to what we're measuring, and use this within a self-supervised learning to start to learn more specific representations towards the data that we actually need. The only one paper I could find when I was doing a look into the self-supervised learning in speech definitely showed it worked well. They used a pick the middle spectrogram approach with an encoder decoder and found that when they did both with conventional features in in-domain testing on the DIAC dataset and both out-of-domain testing, they're able to, so out-of-domain training, they're able to really get a big boost in performance. So I think there's definite promise there. And there's more promise if we think about smarter ways to actually do self-supervised learning. But I think the main issue that we have in speech health is this lack of algorithmic explainability. And one big issue when we're doing AI, doing machine learning on data, is that the machine learning is going to take shortcuts. And we cannot presume that these shortcuts are in any way the same shortcuts that we would take on data. So we can get things like what's known as the clever hands effect. We can see things related in data, or there might be something that's learnt that's related to our class, but without explainability into our algorithms, we can't be ever guaranteed that we've learned something true. We can't assume the form of these shortcuts. We really need to dig into the inner workings of this area a bit more. And the other reason we need explainability is that just using a single evaluation metric, such as accuracy, is an incomplete measure within healthcare. Doctors don't really care if, my system's 80% says that person's depressed. What does that mean to that person within their healthcare pathway? How is our models going to bring about beneficial patient change? We need to think about metrics that actually work within a health system environment. And we need to start to demonstrate that actually using AI combined with speech can start to bring about beneficial change to patients. And there's huge opportunities in the mental health space. Systems such as the NHS in Britain are essentially overcrowded. And with the pandemic, this is happening more and more throughout the world. So there's gaps. People wait a long time between seeing doctors. We could easily be using speech technologies in this space to help monitor people, help gather rich clinical information through here. We've just got to look out and reach for these opportunities that are definitely there. And increased explainability will do that. Metrics don't often reflect clinical applicability, and we need to show these metrics that bring about user benefits. We have other consequences of chasing metrics as well, related essentially to the no free lunch theorem. So this is the theorem that says there is no one universal good model. And when we looked at the slides earlier, that people seem to be generating more and more to this one universal good model of some sort of spectrogram, some sort of CNN setup. But models are only as good as the assumptions we make and the data we use to train them on. Some models are going to do better, some models are going to do worse in different circumstances. And we really need to do rigorous analysis. So it's not enough to say, I spent 3 months developing this CNN system and I spent 2 days developing my baseline system. Of course, the 3-month system is going to have better performance, but have we given it this true opportunity? And again, this comes down to sort of my final point of needing more reporting standards. We've got to look at usefulness and biasness in developed models, understand these systems more, and as I said, be presenting better clinical evidence to clinicians to help them want to adapt our models and start to use them in things like clinical trials. And of course, the final reason for explainability is, of course, bias. Bias happens everywhere. We spoke about bias in the last presentation. It again happens in healthcare. Selection bias is very, very easy to do. We have a problem in psychiatry a lot, where we end up with doing a lot of our experiments on 25-year-old undergraduates from university. They volunteer for our experiments more. We, of course, have human biases. Even with medical labels, biases aren't a ground truth for what might be going on. The skill experience of clinicians can come through in different tests. And of course, we have model biases happening. And there's a lot of research happening again into improving this, into AI fairness, but this isn't drifting through into the health space yet. We have this urgent need to explore the generalizability of these sort of approaches that are coming through in other areas of speech research, in for health applications, and really understand our models a bit more. As well as doing all of this, we also need to consider the view of the patient while we're doing this research. And this idea of co-design or public and patient involvement in research is about not doing research about or on patients, but doing research with patients, asking them what they need from the systems that we're developing. So this can be really useful in data collection. There are some groups, unless you have the right membership, know the right people, have them involved in your research, we're not going to be able to reach out to them. They're not necessarily going to come and volunteer to do a study. We can think about how we're measuring what we're doing. The tests we want to design to get better speech prompts have to be done with patient comfort in mind. If people don't want to talk, we've got nothing. We can't actually do our research. So we've got to make sure that people are happy here. In our analysis, patient insights are really important into interpretation and figuring out what possibly is the best model or best approach. Might, again, not necessarily be the system that has the highest accuracy, but a system that actually suits the patient's needs. And again, in sometimes writing, and we need to write a little bit more in a more sensitive and non-stigmatizing manner about health, and having patients involved when we're actually publishing papers allows us to do this as well. I know this from personal experience. I've had a lot of my writing corrected by patients, and it's good. It's a good experience to remember what we're doing, who we're interacting with, and why we're doing all of this research. And the last point I'd like to make is this idea of reporting standards. And we don't have any reporting standards in speech health research. And as I said earlier, if we don't have this, we're not really tracking usefulness or bias in our developed models. So we need to things like data collection. What device are we using? Is there any evidence into its reliability over time? Are we using established protocols when we're actually collecting the health information? Are we allowing for suitable replication, data processing, model construction, and reproducibility? If we can't share data, we should be making sure that other people can at least verify our models on their own data sets. We need to be thinking about reporting demographic and clinical data, age, gender, ethnicity, comorbidities about the people we're collecting on. This allows for better inferences of what our models are learning. we need to not, at least be describing things by a single factor, but thinking about confidence intervals associated with the models that we're doing. And of course, as I said, in with reproducibility is definitely dissemination, making our code available through open science frameworks and trying to keep that code a little bit up to date as well. So yeah, it's a big overview of sort of how I feel that the area is and going. And as I said, I wanted to remind everyone why speech was this powerful health signal, highlight that AI is really good in combined with getting out these signals. Look at where the state of the art was and think, okay, what do we want to do? Where do we want to go? And if we want to bring about beneficial patient change, how we've got to go about and some of the things that we have to go about adapting it. So yeah, these are the conclusion points. I'll just leave them up and take some questions.
Yeah, thank you very much, Mr. for the presentation. And any questions or any comments? Yes, please.
Thank you for this brilliant talk. I really appreciated it. I just have a comment about sharing the data. In order to share the data, we have to solve this low problem, anonymization problem. And when you want to increase the amount of information, like comorbidity or some other information, you decrease the chance to have anonymized data. So it's a real problem. And one of the unique chance, according to me, to solve it is to stay in the non-profit area when we want to share the data. I don't know if you have some advice on that.
I'm well aware of the irony of presenting a data set yesterday I couldn't share and then telling people today to share data a bit more. So I know that it's exceptionally difficult when you look at commercial development versus academic research. But I think things like better reporting standards, which would allow us to compare models across multiple data sets collected at multiple institutes and open up meta-analysis, gives us that chance to build that powerful evidence base that we need to push speech forward. So if we can't share data, we can share everything else.
And still in this point, in this same direction, one big help for us could be to have official legal agreement, draft agreement really for all of us. In my recent experience about COVID, we start a process to record data and we obtain the right to record data 18 months after. So it was a little bit difficult to maintain the patient in the hospital during 18 months. And we don't have data now. Thank you.
I think these are things that the power of the community coming together to solve these problems will help us.
Thanks for an excellent talk. I first two remarks about data. There is some longitudinal data available. Companies have it. They have call centers and people gradually deteriorate or they have trauma and there is. Excuse me, but they're not willing to share it probably. Second remark is about co-design and the public patient involvement. We've done it in some projects, but the problem is the grant structure in many countries because you only have grants for a couple of years, and if you first have to develop co-design, etc., etc. Okay, but my main question is the insights, the explainability. We have a lot of challenges also in industry. Challenges have many advantages. But the disadvantages, they go for performance, a number, and everybody starts using the same method. So how can we promote research in such a way that we get more insights out of it instead of a lower number?
We need to be encouraging our reviewers to not just be rewarding a good score, and we need to be rewarding good science or even bad scores with good science as well. We need to think about how the review process. I was speaking to people this yesterday. I typically, if I submit a paper here, I expect one reviewer will love it, one reviewer will be a bit indifferent to it, and one reviewer will complain that I didn't use one of those models.
I completely agree, because if I review, one of my standard remarks is, why are the results better? Could you please explain insights? So my recommendation to INTERSPEECH would be one scale that express this. not just a better number or something like that, but that the paper should be, well, has some insights, some explanations or something. If we put that as an extra skill in accepting papers and that, because a lot of people are complaining about it, then we should do something. You think that's
I mean, even things like the chat plots, very easy to do on your best model and give that little bit more insight as to what might be going on. So there are some low hanging fruits we can do. Remembering to do a bit of statistical analysis on the data, looking and, as I said, looking first at, well, what do my conventional speech features give me? Then what does my model give me? And then looking at the insights from explainability, adding all these things up together, we're building that evidence base.
an obligatory section in papers with insights and explanations. Thank you.
I think I'm kind of repeating what the other said. Sharing is a critical point, and whenever we listen to a talk and I ask later on, is this data available? No. Short question, short answer. So do you think that it would be good to set up something like the Mozilla Common Voice, where there's a public collection and patients contribute voluntarily? Do you see a chance in that, or in future home medical application where you can do continuous and longitudinal data collection?
I mean, home longitudinal data sets are collectible, and I'll hopefully have some papers on that later this year. I think, we need to think about getting the right funding bodies together, the right calls, maybe, things in Europe, it's easy to get some of these calls together to start to build a pathological speech data set similar to something like Dementia Bank or the UK Biobank, for example. It would be possible to bring these things together with the right set of permissions. Yeah, it's going to be a bit of heartache in terms of convincing a whole load of Unity ethics boards that what we're doing is correct. But if we're designing with patients in mind, getting these feedbacks through, it will increase our chances of making these things happen.
Thank you.
Other comments? Yes, please.
So this is maybe a suggestion or a question, I don't know what. Since you seem to be closer to the clinical community, do you know how far they are from collecting speech the way, like, every time I go to my doctor, luckily not often, they measure pulse, blood pressure, temperature to gather a speech sample. And that way you have it doesn't solve the sharing problem, but it at least gets you longitudinal data.
I know in the UK health system that they're not really even considering that at the moment.
Okay.
I don't know about other health systems.
Because that would be fabulous. Some years ago at Johns Hopkins, we did a project, and our collaborators were from the University of Pennsylvania, and we were looking at people's written communications and whether they were indicative of mood disorders, suicide risk. And what they had done is, in the University of Pennsylvania medical system, they had asked every patient whether they could have access to their social media, regardless of what they came in for. And a bunch of people gave them permission. And so when somebody was diagnosed with depression, you not only had data from them from that point forward, you had it for 3 years before. And those are the kind of things that are extremely valuable. So
I mean, we just did a study on COVID, and we were able to, not get speech, unfortunately, but we were able to convince people to allow us to enroll in our app and allow us to back harvest their data from their smartwatches in terms of heart rate monitoring and these things. So
is there
Stuff-
is there a legal reason they won't do it? Is there a, what do you, if we said to all doctors, hey, collect some speech from every patient, what would stop them? Do you think?
I think the one thing that I feel is stopping us is we don't know the best way to record that speech yet. And that's what we've got to work on a bit more.
Other comments? Yes, please.
As a follow-up of what Sanjeev said, do you think, I was thinking about that a lot, possibility. People have mobile phones, they phone a lot. Or some people volunteer that sometimes you record your voice. Somebody should store it, I don't know.
I mean, we were able to get like, maybe was negative on the models, but there was still tremendous efforts to collect all that data for COVID-19. And I think it definitely shows the possibilities there. Sorry, someone behind you.
Yeah, the idea of collecting longitudinal data is definitely something that is very valuable. And I don't know if you're familiar with the Framingham Heart Study. The one, I mean, they've got longitudinal audio recordings from, I think, 1960 or something. It's like 40, 50-year long study. And so it's proving to be a treasure trove because patients who've had those recordings have gone through, and some of them are developing dementia and other disorders, and they're trying to do a whole lot of work there. But the point of sharing comes down because ultimately that data is valuable currency for whoever develops methods using that data. I mean, if you look at the Google Euphonia project as well, too, they're trying to collect disordered speech, albeit for assistive technology, but still it's something that they are maintaining ownership of because it provides them with rights to the technology that will be developed. So in the healthcare as well, you know, because they're going to be big healthcare companies involved in these methods, the sharing thing somehow doesn't go together with the healthcare industry.
It
That's what I'm
doesn't,
trying.
I mean, we as a body, I guess, can start to push something back.
I mean, what would be ideal is if you have funding, say, from the NHS or NIH or all these medical-based clinical studies where you're actually collecting that data. If these organizations mandated that the data had to be collected in some form or had to be shared, like we did it for COVID, right?
Yeah.
People worked together to try and find a vaccine for COVID when there was a need, but it all came from because of a need, a mandate. And so I think what is important that we all have to try and influence within our circle, our sphere of influence, that data needs to be shareable. Otherwise, what will happen is people in the tech sector are going to, because they will have, as you said, through smartphones, they will have access to data which we cannot. I mean, Apple is doing it through the iWatch, right? They've developed arrhythmia detection methods because they have access to heart rate from the iWatch, millions of people. And nobody in academia has the ability to access that amount of data. That's just a comment.
Can't really add on to your comment. It's a big problem that we have and big problems that we face with data. But it's better we're talking about them in an environment like this than not talking about them, I guess.
Yes, ma'am.
Just a 10-second suggestion, but maybe it would be good to build a special interest group at ISCA to address all these problems, including the standard of presentation of the results, because we need absolutely. I saw a lot of papers during this conference which are presenting the results in a quite a confusing way for all of us. So at least this part will be done, and maybe I hope at least ISCA is a good place to do it. So the door is open for you now.
Again, we need to talk to ISCA though, because if we're a special interest group, I've talked to a couple of people about this. One of the problems is we'll start publishing outside the main conference more than we were expected to publish in our own workshops and things. So, well, we might be solving some of these problems, but we might get more inward focusing. So we need to get that balance right. And again, these are things to talk to ISCA about can we have a special interest group that's still publishing in the main conference proceedings, still presenting here, not presenting last week or next week.
Hi, very nice talk. I wonder if you can share the slides. Is it possible? Only if it's possible. Yeah, it's really good one.
I'll go through them and see which ones
Think about it.
I can do, and if I decide to do something, I'll put a link up on Twitter.
Thank you. Another thing, I think that database is really, really important because we have either one of two, or we have a real data with real labeling of a physician, but it's very hard. And it's very hard to share because usually the clinics or the hospitals, doesn't allow us. There is an ethical committee and it's so complicated. It's really a problem. And I face this problem every year. The second, like with COVID, there is something with labels, but it's a kind of self-provided label. So we cannot really, be confident about that. So you have something to say about that? How to improve it? I think these are the main question.
I mean, there's power in remote data collection. We've shown through COVID, we've shown through other studies that like remote data collection is useful in terms of gathering data. If we work with patients and sort of look at what else we can collect, so maybe people are willing to spend 5-10 more minutes answering a few more validated questionnaires via an app or via an interface, just to give us that little bit more richness in the data, for example. Yeah, or we start to look at things where people, visit a doctor once every 6 months, for example, or their clinician once every 6 months. We get some clinically validated labels at longer time points, and we're getting more self-reported things in the middle. This could allow us to advance forward as well with richer information, different things we might want to be tracking at different clinical endpoints.
Sorry for disturbing the discussion, but it's the next session. We'll start at 1:30. So can you continue? Our discussion is in break time?
I'll just go outside.
Yeah. Thank you again. To the speaker. Yeah. I would end this session. So thank you very much. To two speakers and all of the audiences joining this session. Thank you.